So what else did we learn about functions? That a function must be one-to-one, meaning each input has just one output. Every time we plug in a number, we should get that same output every single time. So if you look at the table we have here, we have lots of different inputs and outputs. -1 leads to 4, 0 leads to 1, 1 leads to 4, 2 leads to 6, 3 leads to 8. But here we have a duplicate. 1 also leads to 12. Well, that doesn't work. I can't have a function where I plug in 1 and I get out both 4 and 12. So every input can only have one output. There should be just one number. So as it is right now, this table I've given you is not a function. If this last set of values didn't exist, well, yeah, now we have a function because 1 only outputs 4, and that's what we want. We want it to only output one value. So what does that look like in a graph? That means it passes a vertical line test. So if we think of a parabola, this right here is a function. This parabola works. As I pass a vertical line, so if I draw vertical lines all the way across, each time it only hits one point, and it will always only hit one point everywhere we are. But let's imagine a different parabola. Let's imagine actually a square root function. By the way, this is y equals x squared. Let's imagine y equals the square root of x. And I'm going to actually do plus and minus the square root of x. So let's erase that. Let's say y equals both positive and negative the square root of x. So that means our parabola is going to look like this. So now, as I pass a vertical line through it, I hit in two places right here. I hit in two places right here, two places right here. This does not pass our vertical line test. If this is x equals 1, I plug in 1 and I get 1, 2 values. If this is, let's say this is x equals 4, I plug in 4 and I get 1, 2 values. That cannot be true. That cannot be true. So unfortunately, this parabola is not a function. And that's going to be true when we're comparing squares and square roots. So a squared function, x squared, is always going to be a parabola, x squared. But the reverse, the square root of x, is never going to be a function unless we restrict the domain. And that's what we're going to be getting into in a little bit of this module. And actually, that's what I was going to show you here. If I restrict the domain, if I say, well, what if we just choose the positive half of the parabola? What if we just choose those positive square root values? Then, now, it is in fact a function. Well, what if we just choose the negative values? What if we just say y equals negative square root of an x? Now we just have that half of a parabola, so we do have a function. But that's coming in the next task. So for now, we're just going to remember that plus and minus square root of x is not a function because we have those two intersection points instead of just one. So we've talked a lot about what a function is, but now let's talk about what an inverse function is. An inverse function reverses the rule. So earlier I said 2 gave me 4, and 5 gave me 10, and 21 gave me 42. Well, if we're going in this direction like we were before, really simple, that's times 2. But if we're going in the reverse direction, and that's what this is asking us to do now, we're going in the reverse direction. See, going through the reverse direction. Well, what's happening? Well, it's just the opposite. We're dividing by 2. We're dividing by 2. So if the forwards function, f of x equals 2, the inverse function, which we're going to call f to the negative 1, that means inverse, the inverse function is dividing by 2. So f of x is just 2x. F inverse of x, so the reverse, is x divided by 2. So let's make sure that makes sense. Here we're multiplying by 2. The opposite of multiplication is division. We want to see that each time. The opposite is division. The undoing step is division. So our inverse, which undoes the function, should be division. Now we have 3 ways of finding inverses. This is what we found in the 1.2 task. I'm going to briefly state each one, and hopefully you'll get more practice of it in your 1.2 task, your 1.2 homework, and literally every day in this module. First of all, we can solve for an inverse. So let's talk about just the process of solving. If I have a function y equals 2x minus 1, solving for the inverse would look like solving for x. So let's solve for x. Add 1 to both sides. Divide both sides by 2, and we're dividing the whole side by 2, so you can put that in parentheses to really clarify it. And there we go, we solve for x. So that means our inverse function is y equals x plus 1 divided by 2. X plus 1 divided by 2. Again, we're solving for x, and then we just swap our variables. Because it is a new function. It's a new function, which is our inverse. So what about a table? A table is probably one of the more simple. If this is my function right here, I'm going to make a random table of values, 0, 1, 2, 3, 5, 8, 13, 19. Well, when I go to my inverse, and in fact, I'm going to call this my function h. My inverse would be denoted as h to the negative 1 of x. And I would just be switching those values. So 5 would be the input, 0 would be the output. 8 would be the input, 1 would be the output. 13 would lead to 2, and 19 would lead to 3. So again, we just swap our x and y values. They're kind of trading places. And last but not least, let's talk graphs. So in a graph, we are going to reflect across y equals x. And how do we do that? We swap the coordinates. Do you guys see this kind of like thread across all 3? Swap the variables, swap the x and y values, swap the coordinates. So you'll get more practice of this in class, but if we had the point 1, 0, it would become 0, 1. If we had the point 3, 1, it would become 1, 3. And then when we see that actually graphed out, here is our line y equals x. Let's say we had a parabola that looked like this. Reflecting it across the line y equals x would turn our parabola sideways like this. So this is a really quick overview of what we learned on Friday with task 1.2 and how we actually find inverses of functions. Remember, an inverse is something that undoes or reverses the function. So if we were multiplying, now we are dividing. And we have 3 ways to find those inverses. First is just by solving. Solve for that x variable and swap your variables at the very end so we have a new function in terms of y. We could also look at the table and we can just exchange our x and y values. Our old outputs become the new inputs, and vice versa. Our old inputs become the outputs. We are just swapping those variables. And lastly, looking at a graph, we would see a reflection across that line of y equals x, that diagonal line. And we would also see those coordinates switching places. X is becoming y's and y is becoming x's. Okay, I hope this helps just kind of summarize what we learned about functions and inverses.